This is Windows Server Administration, Topic 3, Network Services. And in this topic, we have DHCP, DNS, SSH, and Delegation and Recovery. So the first topic here is DHCP. We should all be familiar with DHCP, and up until now, we've had the server and the client running on a static IP address. So the DHCP process. Now, this should probably have been covered in the CCNA, so I'll not labor this point too much, but there are 4 messages in DHCP. The discover, the offer, the request, and the ACK. And the way to remember it is that the client side always sends broadcast, and the server always replies unicast. So here I have a little diagram which kind of demonstrates the process, the back and forward process. And if you remember as well that the request goes back as a broadcast to let the other DHCP servers, if any, know that the client has decided to accept an offer from the DHCP server that it's indicating. The acknowledgement's fairly straightforward. It's just the DHCP server saying, yes, I accept, that you accept, that I accept, that you accept, that you're going to take this IP address. What we need to know in Windows is the default DHCP lease time is 8 days. Okay, so when you get a lease from a Windows server in a Windows domain, it's 8 days by default, but there's a renewal at 4 days. So the server will check with the client if it wants to keep the lease at 4 days. If that's unsuccessful, it tries again at 7 days. And then if the lease expires, the client machine will roll back to using the API PA automatic addressing, sometimes called APIPA addressing, 169.254 addresses after the 8 days after it expires. So some options in DHCP. You can, through this Microsoft Management Console for DHCP, you can configure various scope options. One of them is you can do a reservation. So if you know something's MAC address, you can actually reserve an IP address for it. And then when it joins the network and asks for an address, the DHCP server will automatically allocate it, the address that you've reserved for it. And this is a technique that I like to use, address reservation, because it saves you doing any configuration on the client side. The client is kind of transparent to the client. It just thinks it's asking for an address, and you have control of which one you're giving it. There's also options in a DHCP packet. So you can send things like details about the DNS servers, details about time servers, and stuff to do with the Windows deployment services as well that we're going to look at in topic 4 can be configured through DHCP. Some other options for DHCP as well, we can do scope splitting. So one server can do 80% of the scope and another server as a backup can do 20% of the scope. We can also do hot standby. Hot standby is when we have one DHCP server sitting waiting in a failover relationship, waiting just in case the primary DHCP server fails. And the other one is a load balanced DHCP server setup where you have 2. The problem with the load balanced is that the 2 servers have to talk to each other to tell each other which addresses they've given out and which addresses are left in the pool. So those are some of the options available in DHCP. Right, the next topic is DNS, and the DNS process, I've broken it down into 7 steps here. This is just a brief overview of it. The user types example.com, and the query is received by a DNS recursive resolver. The resolver queries a DNS root name server, which responds to the resolver with the address of a top-level domain server, such as .com or .net. The resolver makes a request to the .com top-level domain. The top-level domain server responds with the IP address of example.com's name server. The IP address for example.com is then returned to the resolver by the name server. The resolver responds to the web browser with the IP address of example.com. Once the user's PC has the address, the browser is able to make a request for the web page, and the browser sends an HTTP request to the IP address. And obviously, the DNS request gets cached just in case you want to ask for it again later that day. There's no point in doing this every time. So I've got a little diagram here of some DNS name resolution. This was kind of the clearest one I could find online. And this web browser is requesting superhosting.bg, the IP address. So he goes to this root DNS server, and there's various steps in the process we've got here. The thing that we need to know is that when you set up example.com or ec.com as a Windows domain, you had to make the DNS server of your client machine the address of the domain controller. And the reason for that is because the domain controller is authoritative for that domain. So when you do ping ec.com or ping example.com, the domain controller should reply and say, yes, I am ec.com. I am example.com. I am here. And if you say something like, give me cisco.com, then the machine should say, well, I'm not cisco.com, but I know who to ask. I will ask a higher level name server further up the tree from me. So generally, you can have multiple DNS servers configured, such as the 8888 and the 1111. These are publicly available DNS servers that will do resolution for you. 8888 is Google, and 1111 is Cloudflare, I think. I always get Cloudflare mixed up with another company. So, DNS records. Right. A DNS record is just a file in which information about the zone is kept. So the DNS zone for Active Directory is a forward lookup zone, and the forward lookup zone can have multiple different types. So if you have an Active Directory domain server called contoso.com, this contoso.com address is a common example address that Microsoft use. Contoso.com and example.com, you're likely to see those popping up quite a lot. Microsoft use it. An IPv4 address, DNS record, zone record, is called an A record or an address record. That's what A stands for. An AAAA record, 4 A's, is an IPv6 DNS record. Then we have MX records, which are mail records. There's also things like a PTR, a pointer record as well. And this one here, CNAME. A CNAME actually stands for a canonical name. And that's just another way of saying host name. All right, CNAME. So if someone said to you, what's the CNAME of your machine? They actually mean what's the host name of your machine. Okay. Right, DNS caching and logging. So to minimize the number of DNS lookups, if every time you typed facebook.com or bbc.co.uk into your computer and you had to do a huge global DNS lookup, it would slow things down. So DNS records are cached on the machine. So to minimize the number of lookups, we cache them, and we can actually display this in Windows by doing ipconfig/display DNS, or in PowerShell, we can type get DNS client cache. And likewise, we can do ipconfig flush DNS, and the PowerShell command is clear DNS client cache. DNS logs are stored in the event viewer, and by default, Windows doesn't log every single DNS query in the event viewer, because that would maybe fill the disk up, depending on how busy the network is. It is possible to turn on DNS debugging, but Microsoft say a warning not to turn that on in case you fill the disk, because it's going to generate a huge amount of data for every single DNS query, depending on how big the network is. So like DHCP, we've got some options with DNS to kind of configure it. Disable recursion. Right. This means that the DNS server will only respond to requests for which it is authoritative. Okay, it won't forward requests to another DNS server. So what it will do is it will just say, I don't know I don't know where that is, and I'm not the authoritative DNS server for that, so I can't help you. Sorry, bye. That's disabled by default, obviously. Round robin is when you have 3 or 4 DNS servers, and each time a request comes in, it goes to a different one in a round robin kind of way. So the first request goes to the first server, second request goes to the second server, third request, and so on, depending on how many you have. That's a simple type of load balancing that can give us high availability in case of a server failure. So if DNS was very important, you might want to include that. Finally, net mask ordering. This is enabled by default, and this is basically when a query comes in, the DNS client, the IP of the DNS server that responds is the one that most closely matches the IP address. So the longest match, if you think of it in binary, whatever's the closest match. And this is just a kind of simple way of trying to get the DNS server that's closest in terms of the network infrastructure to respond to requests of the closest client to it. One other option with DNS we can enable in Windows Server, and we'll do this a little bit later on in this course, is DNSSEC, domain name security extensions, and we can actually sign the DNS records. So you can create a zone signing key and a key signing key, and then you can tell the clients in your domain to only listen to the DNS server for which it has the key. So this would be a way of preventing DNS cache poisoning or DNS like man-in-the-middle attacks. If someone were to try to put a fake DNS server into your network, if you had the DNSSEC enabled, that could help to prevent that. And it's fairly simple to enable in Windows Server. So we're going to look at that later. So the next networking feature is SSH. So SSH, when we're using Cisco operating system or when we're using Linux, is quite simple to set up. But on Windows, it's a little bit more complicated. So what is SSH? Secure Shell. It's a program to log in to another computer over a network, and we can use it to execute commands or send files. It provides strong authentication and secure communications. So in the lab today, we're going to go through the process of setting up SSH on the Windows server so we can log into it over the network using a terminal emulator or using PuTTY. So we have here 4 stages, just like DHCP, 4 stages. First stage, the client initiates the connection by contacting the server. So you would type into your prompt SSH Michael at IP address, username at IP address. Then the server sends over the public key. Then there's negotiation of parameters and the secure channels opened. Then it'll say to you, do you want to accept the key? And you usually have to type yes. And then you can log in to the host operating system. So it's a little bit complicated to get Windows to do this. You would think, but by Server 2019, they would have SSH installed by default, but it's not installed by default. We have to manually set it up. So that's something we're going to look at today. Right. A different topic now, the delegation and recovery in Windows Server. So we have this feature of the Active Directory called the Delegation of Control Wizard. Now, the Delegation of Control Wizard allows us to delegate different portions of the Active Directory with specific permissions. So from this, you can see here, we can give the privilege, the permission, the ability, the control to create, delete, and manage user accounts to someone, to a member of the domain. So what we could do is we could right click on open the delegation of control wizard, and we could select a specific user and we could give them this. So for example, here's one to say we can delegate the ability to reset passwords to someone through this delegation of control wizard. And this just simplifies the process of assigning permissions to objects in the Active Directory. So that's the delegation of control wizard. Now, let's say we wanted to delegate management of a specific feature of the server. We can do this using the built-in groups, or we could create groups, but there are an awful lot of built-in groups. So let's say you wanted someone to be able to manage and change the DNS scope, create DNS reservations, do things to the DNS features of Windows Server. There's actually already a group built in called DHCP administrators. Okay, so DHCP would be the application they'd be managing. And if you added them to the DHCP administrators group, then that would allow them to be an administrator of DHCP. Likewise, you can, if you wanted someone to change IP address settings and do things, you could add them to the network control operators group. So there's an extensive list here, which we can have a little look at, of all these built-in groups. And there are a lot of them, you'll see. There we go, look. Certificate publishers, backup operators, account operators, DNS admins. So a lot of these are very self-explanatory. For example, DNS admins are administrators of DNS. All right, so if you wanted someone to be a DNS admin, you could just add them to the DNS admins group that already exists. Here's another obvious one, Hyper-V administrators. Performance log users. So we don't necessarily need to know exactly every single one of these, but we just need to know that we can delegate application management to specific built-in groups that are already in the server. We don't have to go away and make a group called DNS managers or DNS modifiers because it already exists. So, right, the directory service recovery strategy. So let's just say your whole Active Directory broke and you weren't running it in VMware like we are. So you couldn't just restore a snapshot, which is what I would suggest doing. It is possible to actually recover a broken Active Directory. And to do this, you can actually recover the whole forest and recover the domain. And this is just a process that you would go through on Windows. So it says that if you do try to recover an Active Directory, the following data will be lost. All objects that were created after the last trusted backup, which seems fairly obvious. If you're restoring a backup, you're going to lose everything that was created after that backup. All updates that were made since the last backup and all changes that were made. So I think it's fairly straightforward in that it's saying that you could recover the entire Active Directory, but you'll only be able to recover what was saved at the last trusted backup. So that's the whole Active Directory, the whole forest being recovered. If you just want to recover a simple object in the Active Directory, like a user, okay? I think I spoke about this briefly in topic 2. What we have is, we have a thing called the Tombstone Lifetime. And the Tombstone Lifetime is when something's deleted, how long it goes into the Active Directory recycle bin for. Okay, so you delete an object, it goes into the Active Directory recycle bin, let's say for 180 days, then a process called the garbage collector removes it. you can go in and change this time here, and you can go in and recover these objects from the deleted objects status, as long as they're in the recycle bin. So let's say you accidentally delete someone's account, and let's say someone leaves the company and you delete their account, but then they come back 2 months later because they missed their old job. Potentially, you could just recover their account if it wasn't too long. Okay, I don't know what implications that has in terms of security. I'm just trying to come up with an example when you might want to do it. Let's say you accidentally delete a group or something. It's okay. You can recover it again, and it should be fine. So this is kind of in place to allow you to recover deleted objects. Now, over here, I've put this image here. This is an example of what the protocol looks like in the background. It's running in the background. And the protocol is called LDAP, the Lightweight Directory Access Protocol. So the LDAP protocol that runs behind the Active Directory looks like this. Okay, there's all these like CN equals this, CN equals that. There's little key value pairs that run. So this is an example of this tool, ldp.exe. And let's say you wanted to make a very, very precise change to the Active Directory, a very precise change. You could go in to this LDAP editor and you could edit things in there. That's if you want to make, they say, very fine adjustments to the domain, such as changing the Tombstone Lifetime or a very specific login time. I would not advise going in here and doing anything unless you really knew what you were doing. I used to work at a big financial company, and there was a few specialists there who were very good at doing things with LDAP. They knew, there was a team that knew all about LDAP, and they were always in here making changes to things. And it's not something I would advise just going in and messing about with. You're likely to break stuff. So that's all of the theory in topic 3. I've put a little link here with a guide to the Delegation of Control Wizard. I had a little search around on the internet, and there are quite a few guides from like the year 2000 and stuff, sort of 20 years old. But this one, relatively recent, September 4th, 2019. And this just takes you through, look, here we are in the Active Directory here, right-clicking on users, and look, it's this easy to get the Delegation of Control Wizard. You right-click on the users folder and you click Delegate Control. And then it says, you know, what do you want to delegate control to? You want to let someone create, delete, and manage INET org person accounts. Tick there, click Next, tick a few other boxes and click Finish. It looks like we can also do this with the Active Directory, or it looks like they've provided some Active Directory commands there. So that's really how simple the Delegation of Control Wizard is. So I'm going to stop the recording now. Let me just do. So, started it with the word so again. I'll edit that out later. Server Administration Lab 3, Delegation and Network Services. So in this lab, we should have our Active Directory domain installed, and we're going to set up some of the different topics or some of the different features of the server that I just talked about. So the first thing we're going to do is use the Delegate Control Wizard to create a group and then add Bob to the group, our test user. And then we're going to delegate some control to Bob. So that's part 1. Hopefully the guide that I put into the PowerPoint should be helpful as well for that. Right, part 2, a little bit more complicated. So in the server, we're going to go manage, add roles and features, and then we're going to install a new feature, which is the DHCP server. Okay, now once we've installed the DHCP server, so I'll just tick here, add, click Next, and then just accept these defaults. Now allow the server to restart itself if it must. Now it's very important that you have the server on a static IP when you do this, because in a DHCP network, one of the machines should be on, at least one of them should be on a static IP. So let's let that install. So if we remember back, at the moment, we have our client machine on a static IP and our server on a static IP. So what we want to do now is we want to get the server to give the client machine an IP address automatically. So let me just go back to the lab here. So this talks you through what I just did there. Go to Server Manager, choose Add Roles and Features, choose Server Roles, choose DHCP. This talks you through this, okay? We're going to create a DHCP scope of 10 addresses. So we're going to start the scope at 10.10.10.100 and go all the way up to 10.10.10.110. So it's a bit of a tongue twister at that. And this, in steps, this shows how to do this. And then what we're going to do is we're going to go to the client machine and we're going to go into the Network and Sharing Center. Let me just quickly dive through this. So we're going to go down here and into here, and then we're going to go to the Network and Sharing Center, change adapter settings over here, right click on our Ethernet adapter, go to properties, put in the administrator. Because we're on a domain now, we have to provide administrator credentials to change this. Because obviously Bob isn't in the network control operators group, he's not allowed to do this. So at the moment, we are statically set to 10.10.10.2. Let's go back over to the server. Right, DHCP is now installed, and you should be able to see, okay, as per our Active Directory groups, that we now have a new tab here, and over here we now have a new tab as well, adding to our set of roles that are on the server. Okay, so let's go to this little arrow up here, and it's going to say complete the DHCP configuration. So let's click on that, and up comes a post-install configuration wizard where we will just literally click a couple of things and say that that's done. What we really want to do though is we want to get into the DHCP manager. So we go to Tools and go to DHCP. It will open up this Microsoft Management Console, the MMC snap-in for DHCP. And what we can do is we can right click on this and we can go to add a new scope. So somewhere that allows us to add a new scope. All tasks. This is where I forget how to, is it IP? Yeah. So we can go to IPv4 and we can go new scope. All right, and it'll take us into a new scope wizard. So we can call this test scope. Okay, and description really doesn't matter. It's just an arbitrary description. And it will say, what's the start IP address? So let's start at 10, 10, 10, 10, 100. And let's end at 10, 10, 10, 110. Now just watch out for the subnet mask there. Defaults to 8 because we're using 10 in the first octet. So make sure we put that up to 24. Nice little subnet calculator there, actually. Now, do we want to add any exclusions? Let's say we had a printer or something inside the scope. We could add that there, but we don't. There's the lease time I talked about earlier. Defaults to 8 days. Do you want to configure the options for the scope? Yes. Do we want to add a router or a default gateway? We might as well say that our domain controller is the default gateway. Let's add that. Do we want to add some DNS servers? Yeah, let's add in the Cloudflare one to be a secondary DNS server after. Now it's going to give us, Now, the reason it's saying it's not valid is just because this server doesn't have internet access yet. Okay, but later on we can just ignore that. Later on we can give it some internet access. Do we want to add Wins servers? No, we don't. Yes, let's activate the scope. Okay, so now we have an active DHCP scope running on the machine. So we jump over to our client and we say, okay, so in here at the moment, we have IPconfig. We have a statically assigned IP address. Okay, and if we do ipconfig/all, it'll say DHCP servers, okay, DHCP enabled. It says no. So what we're going to do, we're going to go obtain an IP address automatically, click OK, and then if we go back in here, okay, that's not too good. Let's see if we can do ipconfig now. Okay, it still thinks we have 10.10.10.2. That's because you need to click close on this for things to happen. Let's see what happens now. Ah, look at that. There we go. 10.10.10.100 is now our IP address. Okay, we've put it on obtain an IP address automatically. And if we do ipconfig/all, we'll see DHCP enabled. Yes, DHCP server 10.10.10.1. Okay, so there we go. So there's some lease expires. This tells us when our lease expires, 7th of October. That's 8 days from now. As I said earlier, when did we get the lease? What's the subnet mask? Okay, so that's DHCP working, and we dive back over to our server and go into the scope and go address leases. We'll see there's our server there. And if we wanted to do a reservation or anything, we can do that here, or a filter. Okay, we could deny, allow through this. We can delete the scope, we can refresh. So often in a big network, this will be full, a few hundred addresses that you can manage it and examine. So that's the DHCP part of the lab. The next one is just a test of DNS operation. I'll let you work on that yourself. That should already be working. It's just a case of creating a couple of screenshots or one screenshot. The final part is SSH. Now, I think, if I remember correctly, for those of us that were with me in last semester doing network security concepts, I think we had a little bit of a play around with this. Setting up on the server, you're going to need to go into PowerShell and you're going to need to run these commands. Okay. Now, I'll let you work through this yourself and see if you can get it working. But what we should be able to do once SSH is installed to prove that it works, okay? So let me do open PowerShell here. This will be the first time we open PowerShell. Just let the RAM catch up. We should be able to do SSH administrator at 127.0.0.1. Right, connection refused. So your job is to get that to work. That should come up and say, you know, do you want to accept the key? Yes, and I'll let you in. If you can get that to work here, then we should be able to SSH in from a different machine. So that's the last part of the lab.